Okay, today we're looking at what they call factor fixing. So we are going to factor with GCFs and by grouping. So factoring is simply the process of breaking up a polynomial into smaller pieces, which we're going to call factors. You can think about it as essentially unmultiplying a polynomial. So before we go ahead and factor, let's make sure we remember how to multiply. So we're going to distribute these first, simplify. So we're going to distribute 2x, both x and 4, both terms. 2x times x is 2x squared. 2x times 4, 2 times 4 is 8, and then we'd have x. Okay, this time you take the whole 3x squared y, we're going to distribute to both terms. So we'd get 3 times 2 is 6. X squared times x is x cubed y. 3 times 5 is 15. We don't have an x, another x, so to just leave it as x squared. Y times y is y squared. Okay, on these next ones, when we want to factor each, you can think about it as undoing distributing. Think about the biggest thing you could pull out of both of them. So 2 and 7, there's no number that comes out of both of them because it's just 2 times 7, 2 times 1 and 7 times 1. So there's no common factor. However, they both have an x in them, so let's divide both of these by x, and we would get the 2 just stays, and x squared divided by x is x. And then we get minus 7, x divided by x is 1, so that's not going to change anything, and then you'd have y. The problem right now is these two expressions, 2x squared minus 7xy, is not the same as 2x minus 7y. So if I wanted to make them the same, think about how we write it when we distribute. We'd have the x out front, this would be in parentheses, and now this is in factored form. Okay, let's do the same with the next one. We've got a 16x cubed, 12x squared, and a 4. You may notice that 16, 12, and 4 can all be divided by 4. And that's the biggest number because you can't take 4 and divide it by anything bigger and have it come out evenly. Okay. If you've got an x cubed, x squared, and x, they can all be divided by x as well. So 16 divided by 4 is 4. X cubed divided by x is x squared. Okay, 12 divided by 4 is 3. X squared divided by x is x. 4 divided by 4 is 1. So is x divided by x. So we get a 1 there. Be careful, you may just say it cancels, but you do want to make sure you write that 1 and not just leave it blank, because then we assume it's 0. Once again, this equation is not equal to our original one. So what do I need to do? I need to put the 4x that I divided by out front such that when you distribute, we'd be back to the original equation. Okay, one last one. We've got a 5 and a 10, so they can both be divided by 5. We've got an x, but the other one does not have an x, so that doesn't work. X squared and x cubed. So they can be both divided by x squared. Okay, so 5 divided by 5 is 1. We've got the x still, y squared divided by y squared is 1. Plus 10 divided by 5 is 2. Y cubed divided by y squared is y. Then we're going to write the 5y squared out front. So, what did we do here in example 1? To find the GCF, which is the greatest common factor, meaning the largest number and or variable that all the factors of your expression have in common. So we found the greatest common factor of all its terms is about bottom line. Then we divided the polynomial. The polynomial is a fancy way to say each of the terms by the GCF, and the quotient is the other factor. If it's helpful for you, quotient is a fancy way to say what you get when what's left over after divided. What's left, what's the result? I should say, what's the result after division? In this case, it's the part we put in the parentheses. And then we express our polynomial as the product of the GCF and the quotient. The quotient is the part with the parentheses. Okay, so if we want to just practice finding the GCF, like if you were having a hard time with that, I do think this is a good skill. If you're feeling pretty good, you're welcome just to kind of skip like the next minute or two and skip to the task. So here, with 24 and 42, you may say, okay, they're both divided by 2. But if you have a hard time and you're not quite sure, I would bring it down and be like, okay, well that's 2 times 12 And then 12 is 6 times 2, and then we get 2 times 3. This 2, 2, 2, and 3, we call that the prime factorization. So meaning you broke it down to the smallest possible numbers. Prime numbers, remember, are only divisible by itself and 1. If we do the same thing with 42, maybe you say, okay, it's 6 and 7. So then we get 2 and 3 again. So we notice they both have a 2 and they both have a 3 in common. And the other parts of the other 2's and the 7 are not in common. So then the GCF of this first one would be 6. Okay. Next, we're going to go ahead and do this one. So we've got 4x squared y cubed and 6x to the fourth y squared. So the GCF here, numbers 4 and 6 are small enough that you probably know the biggest one we can put of both those is 2. We've got an x squared and x to the fourth. So think about taking the smaller exponent, so x squared. We've got y cubed, y squared, so then y squared. This last one, 15 and 5. So the GCF is 5. You've got an x and an x, and then you got an x squared and a y, y squared and a y, so that's just going to be y. So be aware, we do expect you to be able to recognize those GCFs. Okay, so let's actually get to the task. So it says, at first Optima quilts made only square blocks, but now she will start making a line of rectangular quilt blocks. One side of the rectangle she made was x by 5, the other side is x by 2. The design department feels the customers need a different expression to really understand how much bigger the area x by 5 times x plus 2 will be. Write the area in a different expression. So, let's take a look. So remember our side lengths. If we had an x by x, right, that's what made the x squared. And then if we're adding 5 to one side, that was 5 lines. 1, 2, 3, 4, 5. And then the 2 was adding just 1, 2 to the other side. Okay, so if we extend this, this is going to be plus 5. This time it's plus 2. So notice, just like they said, not a square this time, right? We've got a rectangle. So, sorry, gonna just try to erase that extra part down there. There we go. So if we wanted to write this expression, just like we did last time, kind of the last chapter, one way we did it is we'd look at the outside. So they already wrote the outside, the x plus 5, x plus 2. The other way is they wrote the inside. So let's see how many x's we have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 x's. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So this is x squared. I'm going to write it for a minute as plus 5x plus 2x plus 10. And there's a reason why I'm doing that. But we get x squared plus 7x, we said total, plus 10. So this is an equivalent expression. You'll see in a minute why I took that step between. Okay, let's go to the next. Here's some additional new lines of blocks of Optima quilts. Find 2 different algebraic expressions to represent each rectangle and illustrate with a diagram why your representations are correct. Okay, so we got the original square block. So that's x squared, and it's extended by 4 inches, but only on one side. So one side has 1, 2, 3, 4. So this side is x plus 4. This other side is just x, right? There's nothing there. You could put x plus 0 if you wanted. So if we talked about the area on the outside, it's x times x plus 4, which for the record you can just rewrite if you want it as x times x plus 4. And then the other way is these rectangles are x's. So this is equivalent to x squared plus, there's 1, 2, 3, 4 x's. So these are equal statements. Okay. Original block was extended 3 on one side and 4 on the other. So we've got the x squared, and they're saying, okay, extend this 1, 2, 3 on one side, and then 1, 2, 3, 4 on the other. And you may have to kind of fill things in a little bit. Okay, so if this top side is x plus 3, The other side is x plus 4. So if we write the area as the outside, it's x plus 3 times x plus 4. Okay, now let's look at another expression, x squared. I've got 3 x's here, 3x. I've got 4 x's there, so plus 4x. And then I've 12 units, 1 units. So that's the same as x squared plus 7x plus 12. Those are all equivalent statements. Okay. So the customers start ordering custom-made blocks, and the customer service department has placed the following orders on your desk. For each, describe how to make the new blocks by extending the side of the square of the block on your initial side of x. Your instructions should include diagrams with written descriptions and algebraic descriptions of areas of rectangles using expressions representing the side lengths for each. So here we got an x squared. Then it says you've got a 5x and a 3x. To get that 5x and the 3x, like notice the problem above, they had a 3x and a 4x. Notice that related to how long we extend the sides. So it means one of these sides is an x plus 5, and one of these sides is an x plus 3. You see now why I rewrote it in 2 separate ways? So let's extend this side 5. So I've got 1, 2, 3, 4, 5. And then on this side, if I extend it 3, 1, 2, 3, we're going to get something that looks like this. Okay, so now let's write it another way. So we could write it, we know now is the outside area, so this is equal to x plus 5 times x plus 3. Okay, so this one, as we look at it, we've got an x squared. So let's start with a square. And this time you got a plus 4, so it means you're going to extend one side. 1, 2, 3, 4 units. So we've got our x plus 4. And the other side we got a 6x, so we extended it x plus 6. So we're going to have 1, 2, 3, 4, 5, 6. And then do we have 24 boxes here? Doesn't hurt to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We sure do. Or another easy way to say that was 4 times 6 is 24. So yes, we do. So this is equal to x plus 4 times x plus 6. Okay. So here it's saying, okay, that's not too bad, right? You could just simply pull out, the middle term, you see that you've got the 5 and the 3, so therefore it's x plus that 5 is one side and x plus the 3 is the other. So as we look at example 3, I'm going to come back to the directions in a minute, but as you look at this first one, you probably could say, okay, I'm glad in the pattern of this here. When you've got almost, okay, the problem is now we made these a little trickier. How about let's change this? This first one, actually, let's just make it x squared plus 2x plus 7x plus 14. So if I did that, then you'd probably say, okay, well, that means one side's being extended by 2 from the 2x, and one side's being extended 7 from the 7x. So that means, hey, we'd get x plus 2 times x plus 7. The problem is when you get to some of these other ones, you look at it and you're like, okay, I don't really know what maybe the initial side length is, etc. So there is a little trick here. And I'll show it to you with this first one where we had something we recognized, and then we'll do it with the others. So if I take this same problem, I'm going to group the first 2 and the last 2 terms. And I want to know what the GCF of x squared and 2x is. So that's just x. Okay, let's divide it while we're there. So we're going to do x squared divided by x is x, 2x divided by x is 2. So that's what we did kind of in the first part, right? We wrote that as factored form. Now let's look at here, 7x and 14. So 7's the biggest thing those have in common. So this is 7, And then we'd have x, 14 divided by 7 is 2. So let's add that, right, because it's addition between those two. So I just rewrote those first two and those last two terms in a slightly different form. Notice now they both have an x plus 2 in common. So I'm going to think about pulling that out front. And what are you left with? You're left with an x plus 7. So you can almost think about that x and the 7 will distribute to x plus 2. So that's another way to think about it. And this process that we just did over here on the right will work for these other examples. So we're going to group these first two and these last two together. So we've got a 7x cubed and 7x squared. So they both have a 7, and I'm also going to take out the x squared. So 7 divided by 7 is 1. X cubed divided by x squared is x. 7 divided by 7 is 1. X squared divided by x squared is also 1. So x minus 1. We're going to write the 7x squared out front. This one, we do notice there's a 4. Anytime there's a negative between the two groups, we're going to also take out a negative with it. So we're going to take out a negative 4. Negative 4x divided by negative 4 is x. 4 divided by negative 4 is negative 1. And notice because we did that, these two factors match. Otherwise, we would have had negative x plus 1, so they're really similar but don't quite match. And we'd have it minus 4 this time. So think about taking out the x minus 1. What are the two leftovers? You've got 7x squared minus 4. So think about, hey, we did the opposite of distributing here, right? And then that 7x minus 4 would distribute each part to the x minus 1. Okay, two more examples. Group first two, last two. 12 and 15, the biggest those have is 3. A squared and AB is going to just be an A. 12 divided by 3 is 4. A squared divided by A is A. 15 divided by 3 is 5. A divided by A is 1, but I would be left with a B, and it will be negative between those two still. We'd write the 3a up front. Okay, here, 16 and 20, we're going to have a 4. There's a negative in the middle, so we're going to pull that out. So 16 divided by negative 16 divided by negative 4 is positive 4. We still have the A. 20 divided by negative 4 is negative 5. We still have the B. We're going to write that negative 4 out front. Take the common factor, so 4a minus 5b in one set. Take the numbers out front, the 3a minus 4, and the other set of parentheses. Okay, one last one. Do your grouping. Okay, GCF of the first two terms is a 2x squared. This time I'm going to do a little different. I'm going to write the GCF out front. It really doesn't matter if you do it at the beginning or at the end, just make sure you write it. 6 divided by 2 is 3. X cubed divided by x squared is x. 8 divided by 2 is 4. X squared divided by x is 1, so we don't need to write it. Here, 9 and 12, we're going to get a negative 3, right, because there's a negative in the middle. So negative 3 out front. Negative 9x divided by negative 3 is 3x. Negative 12 divided by negative 3 is a positive 4. 3x plus 4 in one set. You've got a 2x squared minus 3 in the other set. And you now know how to factor by grouping. Good luck with the assignment.